Hello class, today we are talking about trapezoids. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, that means a trapezoid is not a parallelogram. No trapezoid is ever going to be a parallelogram because parallelograms have exactly two pairs of parallel sides, and trapezoids have exactly one pair of parallel sides, not at least exactly. All right. Now, the parallel sides of the trapezoid are called the bases. All right. So these two sides are parallel. These are the bases of the trapezoid. The angles are called the base angles. So we have these are base angles, these are base angles, okay? And they come in sets. So these are one set of base angles and another set of base angles, okay? And they are consecutive, all right? The consecutive angles whose common side is a base are the base angles. Now, so they're all base angles, but when you talk about the base angles, you can talk about these two here together, all right? Okay. The non-parallel sides, those are called the legs. Just like you have legs of a right triangle, we have legs of a trapezoid. And they are the ones that are not the bases. They're not the parallel sides. And just like in a triangle, if the legs are congruent, we have an isosceles trapezoid. Just like an isosceles triangle has two congruent legs, the isosceles trapezoid has two congruent legs. Okay? Now, there's not a whole lot with these, but there is some interesting things, interesting properties of trapezoids. And not trapezoids in general, but for isosceles trapezoids. Well, some of it's for general trapezoid stuff, but mostly it's for isosceles trapezoids. So first we have the isosceles trapezoid base angles theorem, not to be confused with the triangle base angle theorem or some other trapezoids, but this is specifically for isosceles trapezoids. If you have an isosceles trapezoid, then each pair of base angles is congruent. All right? So the angles on this base, B and C, are congruent to each other. The angles on the bottom base, A and D, are congruent to each other. The base angles of an isosceles trapezoid are congruent to each other. Now, this does not work for other trapezoids. A and D here, no, not going to be congruent, because this is not an isosceles trapezoid. But for an isosceles trapezoid, just like for an isosceles triangle, the base angles are congruent. All right? And that's the set of base angles, the pair. Next, we have the isosceles trapezoid diagonals theorem. What this says is that if a trapezoid is isosceles, it says if and only if its diagonals are congruent. Okay? When it says if and only if, remember this is biconditional, that means it works both ways. That means if the diagonals are congruent, then the trapezoid will be isosceles. All right? So, isosceles trapezoids, not only do they have base angles congruent, they also have diagonals that are congruent. Now, one thing I want to be very clear on, remember, a trapezoid has exactly one pair of parallel sides. That means even though the diagonals are congruent, this is not going to be a rectangle ever. Okay? A lot of people think that it can be, but it can't, because the definition is that it has exactly one pair of parallel sides, not at least. All right. Last thing we have here is the trapezoid midsegment theorem. The trapezoid midsegment theorem does work for any trapezoid, doesn't matter if it's isosceles or not. All right? And what this says is that the midsegment of a trapezoid, well, what's the midsegment? Let's talk about that real quick. The midsegment of a trapezoid, just like the midsegment of a triangle, connects two midpoints. Now, specifically, the midsegment of a trapezoid is going to connect the midpoints of the legs, not the bases, just the legs. All right? Now, the midsegment of the trapezoid is going to be parallel to both bases, right? Just like the midsegment of a triangle is parallel to that third side, the sides that it doesn't touch. Midsegment of a trapezoid also parallel to these bases that it's not touching. And its length is going to be 1/2 the sum of the lengths of the bases. Okay? So the midsegment of a triangle, remember, is half the length of that other side. Well, here I have two sides, and it's going to be half the sum of those other two sides. All right? Another way to look at this, it is the average length of those two sides. I'm going to write this down. Another way we could do this right here, this could also be written as AB plus the length of CD divided by 2. That will also work, okay, because it's the same thing. Because you multiply fraction, you multiply straight across, so it's this times 1 divided by 2. So let's take a look at some problems with trapezoids. All right. So the first one here is a bit of work. We want to show that a quadrilateral with vertices at 0, 3, 0, 6, negative 6, 0, and negative 3, 0 is a trapezoid, and then we need to decide whether or not it is an isosceles trapezoid. And whether it is or not, we need to tell what is the length of the midsegment of the trapezoid. All right. So here we go. Let's see here. Let's draw this. First, we've got to figure out where to put the axis on this. Let's see. So let's look at the x's. Go from 0 to negative 6. And that'll fit if I push it over here. So that's what I'm going to do. I'm going to push my axis way over here so the x's will fit. And I can do this at the scale of 1. And the y's, I'm going from the positive 6 down to 0. So if I move it down, I should have room this way as well. Okay, so here's my axis. Axes, there's 2 of them. So my axes. And we need to draw this in. We'll use this one blue. Why not? Okay, so Q is at 0, 3. Right here, that's Q. R is at 0, 6, or 3, 4, 5, 6. That's point R. S is at negative 6, or negative 1, 2, 3, 4, 5, 6. And T is at negative 3, 0. So negative 3, 0 right there. T, connect my dots because I want to use a straight edge. Don't ever want to freehand anything because then it looks all screwy because I am a terrible artist. You can ask any of my students. Nothing I draw is ever done to scale because I can't do that. Okay, so here we go. Quadrilateral QRST. Hopefully it is a trapezoid. How do we know if it's a trapezoid? What was the major defining definition of a trapezoid? Well, it was exactly one pair of parallel sides. Exactly one. So we need to show that we have one set of sides that's parallel and one set that is not. Parallel sides, if we're looking at parallel on a grid, that means we're looking at slope, right? So let's take a look here. The slope of side RS. Slope is rise over run, or change in y over change in x, x1 plus x, y1 plus y minus y2 divided by x1 minus x2, however you want to do it. I like rise over run. This is easy enough. Go from S to R, because always go from left to right, and we're going from, where are we at? Negative 6 to 0, and from 0 to positive 6. So we're going up 6, we're going right 6, so that is going to have a slope of up 6, right 6, that's 1 over 1, so that is just 1. Here, from T to Q, all right, and so that, you'll notice we still have up 1 over 1, up 1 over 1, up 1 over 1. So here we have a slope equals 1. So they have the same slope. Same slope. And therefore, segment RS is parallel to segment what is this? QT. QT, there we go. That's QT. Sorry. All right, so segment RS is parallel to segment QT, which is what we need, but we have to make sure that the other two are not. And so let's see, ST, that's a horizontal line. So a horizontal line has a slope of 0, and RQ, that's a vertical line, which remember that is a slope of undefined. Undefined and 0 are not the same thing, so those are not parallel. So this is a trapezoid because we have exactly one set of parallel lines. So that takes care of that. Now let's see what was next. Is it isosceles? Well, if it is isosceles, then what that means is that the two legs, RQ and ST, have to be congruent to each other, right? So these are on grid lines, so we can just count this. We don't have to mess with distance formula on these. So just 1, 2, 3. The length of ST equals 3, and 1, 2, 3. The length of RQ equals 3. Those are the same, and so since the ST is congruent to segment RQ, it is in fact isosceles. So yes, isosceles. Isosceles. I cannot spell isosceles. E-L-E-S. Isosceles trapezoid. There it is. Well, that can't be read very well, can it? Isosceles trapezoid. Just get rid of that pen. Give me that black one back. Try that again. That's a little bit better. Isosceles trapezoid. It is. Okay, so now we need to find the length of the midsegment. That's going to be a little bit more difficult. If you remember, the length of the midsegment is going to equal, we'll just call this x. X is going to equal 1/2 the length of the two bases added together. So that is going to be 1/2 the length of QT plus RS. Right? So that means we need to find the length of QT and we need to find the length of RS. These are not on the grid lines. They're going at angles here, so we are going to have to use the distance formula. Or, if you're like me, I don't really care for the distance formula. I'm going to look at this as Pythagorean theorem. So let's find the length of QT first. QT equals, Pythagorean theorem is the square root of a squared plus b squared, right? So QT, I'm going to have this little imaginary right triangle here using the grid lines, or you could go this way if you really wanted to. That's fine too. And so one side is 3, so that will be my a squared, 3 squared, plus the other side of this imaginary right triangle formed with QT, which is 1, 2, 3. So 3 squared. There it is. So the length of QT is equal to the square root of 3 squared, which is 9, plus 3 squared, which is 9, and 9 plus 9 is 18. So that is the length. That does not have a nice, pretty square root, does it? No. So we're just going to leave it like that. We're just going to call it the square root of 18. All right, so I'm going to go ahead and take that and plug that in right here. So x is equal to 1/2 the square root of 18 plus something else, whatever RS is. So there's RS. Okay. So RS, we're going to do the same thing, square root of, and then let's see here. Once we're going to have this little imaginary right triangle here using the grid lines, because that way I can just count the lengths here. And it went up 1, 2, 3, 4, 5, 6. So A will be 6 squared plus, from here we're going over 1, 2, 3, 4, 5, 6. 6 squared. All right. So RS is equal to the square root of 6 squared, which is 36, plus 6 squared, which is 36. And 36 plus 36 is 72. And again, that also doesn't have a nice pretty square root. So we are not going to get a very pretty answer here. Square root of 72. And for that, I'm going to use my calculator. Turn it on, clear all that stuff out. Okay, so we have 1/2 times the square root of 18 plus the square root of 72, from under there, close parentheses, and I end up with approximately 6.36396. So we'll just round to 2 decimal places and call this approximately 6.36. So the length of the midsegment is going to be approximately what was it? I already forgot it. 6.36. 6.36. All right. So there it is. We have shown that it is a trapezoid because we have these with the same slope and therefore parallel. We have shown that the legs are congruent, and so it is an isosceles trapezoid, and then we found the length of the midsegment. Right. So that did take a little bit of work. The rest of this, not so bad. Okay, let's see. Number 2. For 2 and 3, we need to find the measure of each angle in the isosceles trapezoid. And notice it does specify that this is an isosceles trapezoid. All right. So that means the legs are congruent, and we had 2 theorems that can help us out. So let's see here. We're going to need each angle, so let's just start with the angle that I'm given right there. The measure of angle M is 23 degrees. Now, what are we going to do with the rest of this? What do we know about the angles of an isosceles trapezoid? Well, if it's an isosceles, then each pair of base angles is congruent. All right, so that means M is going to be congruent to another angle, right? Well, M is on this parallel line, so this base, so the other parallel line, there we go. L is the other one on that base, so that means these two are congruent. So the measure of angle L is going to equal 23 degrees as well. Now here comes the other part. How do we find J and K, right? Well, here we go way back to when we first started talking about parallel lines, back in chapter 3. And we said that if you have parallel lines cut by a transversal, remember, same side interior angles are supplementary. So that means this and angle J are going to add up to 180 degrees because they're supplementary. So we're going to take 180 minus the 23 we have there. It is 7, borrowed from that, so that's a 7 now, and that will be 5 and 1. So that means that the measure of angle J is equal to 157 degrees. Right. Angle K, well, it's a set of base angles with angle J, so it's going to be congruent to angle J. So the measure of angle K is equal to 157 degrees as well. All right. I would like for you to pause the video and work out number 3 on your own. All right, you're back. Let's see how you did. Again, this one's not marked as being congruent. Number 2, it was marked. But in the instructions, it tells us that these are going to be isosceles trapezoids. So we know that these have to be congruent to each other because it's isosceles, and that means the legs are congruent. Okay, so let's see. They gave us the measure of angle K, which is 118 degrees. And it's isosceles, so the base angles are congruent. So the angle that is paired up with K is going to be along the base, the parallel side, and that's going to be J. So J is going to be congruent to K, so that is 118 degrees. So now we've got to figure out the other ones, and we're going to do it the same way. These two that are not base angles with each other are going to be supplementary. So the measure of angle M is going to equal 180 minus the measure of angle K, which is 118. So that's a 2. We had to borrow and make that a 7, so that is 62, and that's is 62 degrees. And the measure of angle L, well, it's going to be the same as M because they're on the base and it's isosceles trapezoid. So the measure of angle L is equal to 62 degrees as well. All right? So that's not too bad. That's actually pretty easy stuff. Okay, so last 3, this is going to be looking at the midsegment theorem. All right, the trapezoid midsegment theorem. All right. So, and 4 and 5, we need to find the length of CD. In number 4, it is the midsegment. We know it's the midsegment because it is connecting midpoints of the legs. And our formula for that, CD is going to equal 1/2 times this one, the 2 bases added up. So 12 plus 36. All right. So let's see, CD equals, let's see, 12 plus 36, that would be 48, and half of 48 is 24. So that's easy enough. We could just work it out or stick it in your calculator if you really wanted to. Let's take a look at number 5. Number 5, this time they did not give us the length of the they gave us the length of the midsegment, and we need to find the length of one of the bases. So that makes it slightly more complicated, but not much. So what we have, the length of the midsegment, 1.8, equals 1/2 the length of the two bases, so that would be CD plus 0.6. Okay. So we add it by two bases, multiply by 1/2, that gives us 1.8. So to work this out, we are not going to distribute that in, because then we're going to have all kinds of fractions, and this is going to be really weird. So we're not going to do that. Well, instead what we're going to do is divide it out. And how do you divide by a fraction? That's right, you multiply by the reciprocal, right? So instead of dividing by 1/2, what we are going to end up doing is multiplying both sides by 2. Right. So we're going to multiply both sides by 2. 2 times 1.8 is 3.6. And now that 1/2 is gone, that cancels out, and we're just left with CD plus 0.6. Subtract 0.6 from both sides, and that's easy enough. That just leaves you with 3.0 equals CD. Or you could just say 3. That's also good. All right. So that's not bad. Easy enough. A lot easier to find the midsegment when you actually have lengths. You're not having to calculate distance formula and stuff. All right. So here we go. Last problem. We need to find the value of x. Okay. If you'll notice, these are all parallel. And not only that, this segment in the middle is connecting midpoints of the two legs. And so that means this is the midsegment. So we can use our midsegment formula again, same thing we had a minute ago. So 3x minus 2 is equal to 1/2 times the sum of the two bases. So x plus 11 plus 3x plus 3. 3x plus 3. Okay, now we could, of course, distribute that 1/2 into the parentheses, but that would be a big mess and not fun at all. So we're going to do like we did up here. We are going to multiply both sides by 2 to cancel that 1/2 out. All right, so we're going to, give me this so I can do it in difficult. Multiply this by 2, and then we're going to multiply all of this entire side, by 2, right? So this I am going to have to distribute it, but this is just going to cancel out. That'll be fine. It's so much nicer to multiply by 2 than it is to multiply by 1/2, right? So all of this is going to go away, and so actually, you know what? I'm going to combine like terms as I do that. So x plus 3x is 4x. 11 plus 3 is 14. There we go. And now let's distribute this stuff in. So 2 times 3x is 6x. 2 times negative 2 is negative 4. All right. So let's solve for x. First, we're going to move the 4x over. It's minus 4x minus 4x. We need to get rid of the 4, so we're going to add 4 to both sides. So that's gone. That's gone. And I'm left with 2x equals 18. Divide both sides by 2. And now x equals 9. So that one took a little bit more work than the other ones, but still not terrible, right? Not terrible. All right, so here we go. This is trapezoids. Just to recap, trapezoid has exactly one pair of parallel lines, not at least. It cannot have two pairs of parallel lines. And base angles are in sets. You have a pair of base angles on each base, which are the parallel lines. The non-parallel lines are the legs. If the legs are congruent, it's isosceles. If it is isosceles, those sets of base angles will be congruent to each other, and the diagonals will be congruent to each other. Okay? And lastly, the midsegment of any trapezoid is going to be half the sum of the two bases. Hope you found that useful, and I will see you next time.